Looking at the numbers and character strings that define a dataset is rarely useful. To convince yourself, print and stare at the US murders data table. You can do this with this code. What do you learn from staring at this table? How quickly can you determine which states have the largest populations? Which states have the smallest? How large is the typical state? Is there a relationship between population size and total murders? How do murder rates vary across regions of the country? For most human brains, it is quite difficult to extract this information just from looking at the numbers. In contrast, the answer to all these questions are readily available from examining this plot. We are reminded of the saying, "A picture is worth 1,000 words." Data visualization provides a powerful way to communicate a data-driven finding. In some cases, the visualization is so convincing that no follow-up analysis is required. The growing availability of informative datasets and software tools has led to increased reliance on data visualization across many industries, academia, and government. A visible example are news organizations that are increasingly embracing data journalism and including effective infographics and charts as part of their reporting. A particularly effective example is a Wall Street Journal article showing data related to the impact of vaccines on battling infectious diseases. One of the graphs shows measles cases by U.S. state through the years with a vertical line demonstrating when the vaccine was introduced. Another striking example comes from the New York Times. This article showed data on scores from the New York City Regents exam. These scores are collected for several reasons, including to determine if a student graduates from high school. In New York City, you need a 65 to pass. The distribution of the test scores forces us to notice something somewhat problematic. The most common test score is the minimum passing grade, with very few just below that value. This unexpected result is consistent with students close to passing having their scores bumped up. This is an example of how data visualization can lead to discoveries which would otherwise be missed if we simply subject the data to a battery of data analysis tools or procedures. Data visualization is the strongest tool of what we call exploratory data analysis. John Tukey, considered the father of exploratory data analysis, once said, "The greatest value of a picture is when it forces us to notice what we never expected to see." We note that many widely used data analysis tools were initiated by discoveries made with exploratory data analysis. Exploratory data analysis is perhaps the most important part of data analysis, yet it is often overlooked. Data visualization is also now pervasive in philanthropic and educational organizations. One example comes from Gapminder. In the talks, New Insights on Poverty and the Best Stats You've Ever Seen, Hans Roslings forced us to notice the unexpected with a series of plots related to world health and economics. In his videos, he used animated graphs to show us how the world was changing and how old narratives are no longer true. It is also important to note that mistakes, biases, systematic errors, and other unexpected problems often lead to data that should be handled with care. Failure to discover these problems often leads to flawed analyses and false discoveries. As an example, consider that measurement devices sometimes fail and that most data analysis procedures are not designed to detect these. Yet, these data analysis procedures will still give you an answer. The fact that it can be hard or impossible to notice an error just from the reported results makes data visualization particularly important. In this course, we will learn the basics of data visualization and exploratory data analysis. We will use motivating examples. We will use the ggplot2 package to code. To learn the basics, we will start with a somewhat artificial example, heights reported by students. Then we will cover two of the examples we mentioned, world health and economics, and infectious diseases trends in the United States. Note that there's much more to data visualization that will be covered here, but you will get a very good introduction to the topic.